Hello guys. So in this video we'll see how we can use a potentiometer to vary a voltage or to vary the given resistance. So basically we use potentiometer if we want to vary the flow of or to limit the flow of voltage. So you might see a real life application like regulators used for fan controlling the speed of fan, right? So you have somewhat similar mechanism in potentiometer. So we'll be seeing using potentiometer how can we control this flow of voltage. So for that, what are the components required for this experiment? So we need a potentiometer, approximately 1 to 10 kilo ohms potentiometer. Then we need an Arduino Uno, and you may use a breadboard if you don't have your potentiometer soldered. I have my potentiometer here which is already soldered, so I won't be requiring a breadboard, but you can use a breadboard if you are not soldered the potentiometer. And you need three jumpers, or you can say wires, in order to connect it to the Arduino. Because I already have it soldered, so I won't be using jumpers here. I already have it soldered, but you can use a breadboard and jumpers in case if you have your potentiometer not soldered. So potentiometer, you can see it's a very small sensor here with a small knob, you can see. So I have put a tape here so that you can see this, and you can vary this, you can in fact move this, right? So how does this actually potentiometer work? So to understand the working, we have to see what is this potentiometer and internally how it works. So you see potentiometer, it is a simple 3-pin sensor in which one you give your voltage, that is your 5 volt, in one you have your ground, and the center pin you check for data, in which your center pin, whenever you try to change the data, whenever you try to move this knob, so you see based on your knob moving, there is resistive material which changes the resistance. So for your towards your extreme left, you have infinite resistance, which means zero voltage, and coming towards the extreme right, you have zero resistance, which means you will get complete 5 volt. That is, if I've given here 5 volt input, I'm completely getting here 5 volt output in this center pin. So this is the simple connection and working of your potentiometer. So let's check what's the connection and how do we connect, and then we'll get going with the software part. So coming to the hardware part, as I said, you need a breadboard, Arduino, and a potentiometer. So you can take a potentiometer, and if you don't have it soldered, you can just put it on the breadboard. Now after that, as I said, the connection, you have VCC, ground, and the center pin is for data. Now you can place VCC ground line either side. Yes, the only difference is either from 0 to 103, 1023 to 0. So that won't matter. So I'll take this extreme right side and I'll put it to 5 volt of my Arduino. I'll quickly go and organize this wires well. Then this extreme end, I'll quickly go and put it to ground of my Arduino. And the center pin, I'll put it to A0. That is my analog pin, because I have to read the voltage, right? So in order to read the voltage, I'll put it in pin number A0. So I'll quickly go and change the color of the wires. I'll put the center pin yellow, that is the data signal pin. This is red, that is 5 volt supply, and I'll put this black, that is going to the ground. Okay, so this is a simple 3-wire connection to the potentiometer. So same thing what I have done here in the pin diagram, same thing I'll be going and connecting here. So you can see I have 2 blue wires and one center is the green one. So the green one will go to analog pin. So I'll take this green and I'll put it in pin A0. And then this, as I said, you can connect it to either ways, 5 volt and ground. So I'll put this one pin. I'll quickly grab a jumper. Okay, so I can put here 5 volt, and for ground, I get a jumper. I'll put it in ground. So this is the connection. Okay, so we have connected this. We have given the three wire connection as shown in the diagram here. So now I have this connected. So now we'll quickly go to the software part. So we have to write a simple Arduino code to read the analog value, because we have the analog data going in A0. So we need to write the program to read a simple analog value. So I'll quickly go and create a variable called as pot, which is nothing but I have fixed it to pin A0. Yes. After that, I'll go and set the mode. So as you know, you have to set the mode to input. Why? Because I'm reading the data, right? So I have to set the mode as input, and then here I have to write the code to get the data. So I'd say int of val is equals to analog read. Because I have an analog pin, so I'll be using analog pin because the value is continuous. If it was discrete 0 1, then I could use digital read. Then I have to display this value in the console, right? So for that I have to quickly go and start my serial monitor. So I'll say start at default baud rate 9600. Then I'll say serial dot println, and I'll simply print the val. So this is the simple program. So now we are done with the software part and we are done with the hardware part. So now we can quickly go power up the Arduino and upload the code. Okay, so I've powered up my Arduino. Now I'll quickly go and verify the port and board. So yes, verified. So now I can go and upload the program. Okay, so it's compiling. So the compilation is done. So I can quickly go and get the serial monitor. So now once I have, you can see the value. So I'll try to change the knob. So see, as and when I'm changing my knob, the value is changing. So now I'll try to increase my knob. So you see the value is increasing. Okay, I'm touching the wire. That's why there is fluctuation. So you can see as and when I'm changing the value, as and when I'm moving the knob, see, it changes the value. Yes, but this is giving me an analog value, but I need to have a voltage, right? So I'm giving 5-volt input, so I need the value in terms of voltage. So I don't want this analog values, I want the output in terms of voltage, that is what is the voltage supply I'm controlling. So for that, what we'll do is we'll close the serial monitor, we'll disconnect the Arduino, we'll do few changes in our code. So first, let us try to analyze what we are doing the changes. So here in our case, let me tell you, in our case, I'm getting 1023. Okay, so in our case, I'm getting the value 1023 if my voltage is completely 5 volt. Yes. Now for a given threshold value, whatever I'm getting analog value from the user, I have to calculate how many volts I will get. So all you have to do is you can simply cross verify. So whatever is my value I'm getting, if I multiply by, if I divide this, so if you cross multiply, we'll have 5 divided by 1023. So this is the simple formula, right? So for 1023 analog value, it means I'm getting complete 5 volt. So for a given varying value, what if it is in 200, 300, for a given varying value, what should I do? So I'll just cross multiply. So 5 into here will give x val. So 5 into x divided by 1023. Yes. So that is nothing but equal to 5 divided by 1023 into our value what we are getting. So quickly we'll put this formula in our code. So I'll say int of, I'll say volts is equals to, as I said, val into, then we have to divide. So I'll say 5 divided by 1023. So now if I divide this, I'll get in terms of voltage. So now I'll display voltage. So I'll give system.out.print, and then I'll give println, and I'll print the voltage. Yes. So now we can connect back our Arduino. We can upload this program and verify whether instead of analog value, am I getting output in terms of voltage. Okay, so the program is being uploaded. So now we'll go to tools, we'll check serial monitor. So now I'm getting 4 volt. Yes. So now if I try to change the knob, see, now it is been decreased to 3 volt. So now 3 volt it is restricted. Now I'm again changing. So it is going to 2 volts. So again I'm changing the knob, it is going to 1 volt, and then have completely changed the knob. Further I cannot change, so I'm getting 0 volt. So again I'm bringing back, so I'm getting 1 volt, then again I'm bringing back, I'm getting 2, 3, 4, and the max I'm getting. So you're understanding how using this potentiometer I'm controlling the flow of voltage. So using this, if you have some applications where you can integrate this, if you have to limit the flow of voltage, and based on the flow of voltage you have to control some appliances, so you can use this. Say for example, you have a motor and you have to move that motor based on the voltage here I'm varying. So if I'm giving higher voltage, so it should move faster. If I'm giving lower voltage, it should go slow. So the motor should move slower. So you can control various sensors and application using potentiometer. So wherever you see where you have to control the flow of voltage, you can straight away go and use this cost effective small 10k resistance potentiometer.